Good day, viewers. Welcome to our YouTube channel and to our Facebook page. I hope you are doing well wherever you are watching this video from. Alright, so we continue looking at linear programming. This is our lesson 2. So to those who are following our content, we did tackle lesson 1. Now we are on lesson 2. Okay, so we are still looking at plotting inequalities. Okay, we are still looking at how to plot the inequalities. So we have our first example here. And our first example is saying plot the inequalities below and shade the unwanted region. Indicate clearly the unshaded region by labeling it what? F. Okay, that's what they want. So if you remember what we discussed yesterday, we did say something about linear programming. We said this is one of the branches of mathematics that deals with maximization and minimization of what? Linear functions subject to what? Constraints. Okay, so these constraints can be inequalities or equalities. And we also said that this this lesson or this topic, linear programming, is widely used by businessmen, used by engineers, and used in various companies if they want to maximize their profit or to minimize the cost. That's why this branch of mathematics is very, very important. Okay, so let's get to it. So how can we now plot this on the Cartesian plane? Okay, so I'm sure we understand when we say the Cartesian plane. So let's see how best we can answer this question. All right, so we have, these are the inequalities that we are given. So what we are going to do first, I'll look at the maximum value here. I've got 4. I'll just, when I draw the two axes, okay, like this. Then we'll say this is y-axis, this is our x, the origin. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So start with the first one. This one, which is saying x less than 4. X less than 4. Okay. So identify in the x-axis where x is less than 4, or where x equal to 4. Where x equal to what? 4. So in the x-axis where x is equal to 4, it's here. Okay. Now they are saying less than what? 4. So before we go into that, let's identify the type of line that we are going to use. If you remember, it's just saying less than, it's not equal to. So if it's less than, yesterday we said you use a what? A dotted D line. Okay. So here we're going to use the broken line like this. This is the broken line. That is if it's just less than, not equal to. This is the broken line that we are going to use like this. Then we come back to the condition of this inequality. X less than 4. X less than 4. So we are looking at the numbers that are less than 4. The numbers that are less than 4, we have numbers such as 3, 2, 1 coming down here. Okay. So 4 is not part of the solution set because it's not equal to itself. So those that are less than 4 is 3, 2, 1. So coming here, this side, this is the wanted region. Okay. So in the previous lesson, we said we shade the opposite. Okay, even the question is guiding us. You shade the unwanted region. So if this side is the wanted region, the unwanted region is this side. So we are going to shade that side. Okay, to even indicate x equal to 4. Okay, then we come to the second one. This is our second one, which is saying x plus y greater or equal to what? 4. So on this one, I'm going to explain it in two different ways. Okay, So the first one, when you look at the variable x and the variable y, their coefficients is 1, okay? The coefficient of x is 1, and the coefficient of y is also what? 1. If it's like this, you can just go on the point in the x-axis where you have this value, okay? And you go in the y-axis where you have this value, then you plot just like that, okay? If you don't want to do it like that, what you can do is you come up with a table of what? Values, okay? So where you say we have something like this, x plus y, we change this into an equation, x plus y equal to 4. Then our table of values is going to be like this, okay? This is our table of values. So we have x, y. So we are just going to assume, that x is equal to 0. So here, if x is equal to 0 in the x-axis, make sure you use the coordinates that are in the x-axis. So you can either use this coordinate, this, that's fine. So we assume that x equal to 0. Okay, so if x is equal to 0, what is the value of y? It means where there is x, I'll substitute with 0 plus y is equal to what? 4. So this will mean y is equal to 4. Okay, so here we are going to have 4. So again, we can also assume if y is equal to 0, where there is y here, is equal to what? 0 in this case. So if we assume like that, it will mean where there is y, we are going to put a 0 to be x, we are using this, plus 0 is equal to 4. So x is equal to what? 4. So the reason why I'm doing this, I want you to understand that you get something which I said you go straight, okay? If you don't want, you can even pick these coordinates. If x is equal to 5 and y is equal to 5, meaning it will come on this line, okay? On these coordinates are the ones that you are going to connect. Now I will say if x is equal to 0, y equal to 0, okay? So I've got now these coordinates 0, 4. So I have to plot them 0, 4, 0, 4. So we have to plot these coordinates 0, 4, 0, 4. So if you remember in the previous lesson, we did say the y-axis is the line x is equal to 0. So 0, 4. We are going to plot here. This is where our point is going to be 0, 4. Okay. Then we have this one 4, 0. This is the line y equal to 0. So 4, 0 is the point is going to be here. Going to be there. So I've got this point and that point. The 2 points, just 2 points are enough. Okay. 2 points are enough. If you decide to put another box here, you're still going to have something like this, okay? So just 2 points are enough. So what you do now, you get your ruler, then you connect this point and this point. So before you do that, you come back to your question, okay? What type of the inequality are you using? You're using this inequality, which is just saying greater or equal to. So you're coming up with a solid line. I hope I've made myself clear on this point. So we're going to come up with a solid line connecting this point. This is a solid line, okay? This is a solid line. Let me just make it pass here. This is a solid line. Now, this solid line, they are saying greater or equal to. If you remember in the previous lesson, we said the upper region is greater, then the lower region is what? Less. The upper region is greater, then the lower region is less. So the upper region is satisfying this condition, okay? So we shade the opposite. So our opposite will be this. This is where I'm going to shade. This is our opposite. Don't forget to name your line. So this line, we said it's x plus y equal to what? 4. Like that. I hope you are following. Then we come to the last one. This is our last one. Y less or equal to x. For this one, no need to draw this, because if you need to draw this, it will give you the same line. Okay. So if you remember, I did say that one of the properties of the graph is that we have got a line that passes here. This line is y equal to what? X. So as you can see, you have been given something like that. Y less or equal to x. So let's see, we're having equal to, less or equal to. So I'm coming up with a solid what line. So we get a ruler. Yeah, that is our solid what line. Now it's saying less or equal to. Less or equal to. So this region coming down is less. The above region is greater. So the condition that is satisfying this inequality is down here. This is the wanted region down. But we shade the opposite, the unwanted region. So the opposite, you shade up there, like that. Then we name our line y equal to x. So they said, indicating clearly the region where the solutions must lie, and you label it what? F. So when you look at this region here, you can see that this is where all the solutions of the inequality are lying. So we label it what? F. Okay, so this is how best we can answer this question, as simple as that. Just to make a note that sometimes if you are changing these inequalities into equations, you may find that you end up dividing, okay? You end up dividing. For instance, if you have something like 2x greater than 4, just giving an example, if you divide like this, you just say x greater than 2. You are dividing with a positive value, okay? So I just want to make something clear. You are dividing with a positive value. But if you are dividing with a negative value, this sign, the inequality sign changes, okay? So it's greater than, it will become what? Less than, because we are dividing with a negative value. So take note of this. Thank you so much. Now go to our example 2. All right, so we are just from answering our first example. Now let's look at example 2. Okay, so in example 2, you are specifically going to look at how to describe the unshaded what region. Okay, so in the previous lessons, if you are following nicely, we are just plotting the inequalities. We are just plotting them. We are creating them. Okay, so here you are given something that is already what plotted. As you can see, these inequalities are already plotted. So if they are already plotted, they are just now asking you to describe the unshaded region. Okay, so it's important that if you are given such a question, you identify the lines that are easy for you first. You start with those that are easy. Then you end up with the one that you feel it's complicated. Okay, you make it the last one. So the question is, write 5 inequalities to describe the unshaded region. Okay, write 5 inequalities to describe the unshaded region. So what are we going to do? So I've said you start with the easiest one. Okay, so the easiest one, you can see we have this one here, it's shaded, this side is shaded. We also have this line. Okay, we have this line, it's the easiest one. We also have this one, the easiest one. Then lastly, we can end with this one, which is passing there. Okay, now we start with this one. That is our first one. Okay, so here I will say, what is this line? What is this line? So we are saying solutions. What is this line? What did we say? We said this is the line x equal to what? 0. If you remember, this is the line x equal to 0. So if you know that, you are going to write like this, x, then here you leave space, you write 0. So why am I leaving space? I want you to be able to understand which type of inequality you are going to put here. Okay, so looking at where it's shaded, and remember what I said, this is a solid line and this is a solid line. So this is a solid line, so it should be equal to. So the shaded part is the less. Okay, the shaded part is less. They want you to describe the unshaded part, the opposite. So the opposite is greater. Okay, so the opposite is greater. So this is x greater or equal to what? 0. This is our first one. Okay, for this one, I'll even rename it. I'll say x greater or equal to 0. Then we come to our second one. So our second one, we can come to this one, which is here. So this is the line x-axis, and here it's 1. Okay, so what type of line? We can see that it's a solid line. So we understand that this is x-axis and it's at the point x equal to 1 here, x equal to 1. So I'll write x then 1. So what type of inequality am I going to write here? So what is the shaded part? The shaded part is less. Okay, less, less. Coming here is less. The unshaded part is greater. This side is greater. Okay, so I'll say I will write greater or equal to the opposite. Okay, here it's less, so we are describing the unshaded part, which is the opposite of this side, which is the greater. Greater or equal to. Where am I putting greater or equal to? Because of the solid what line. I hope you are following. Then we go to the third one. So allow me just to write the name of this. I'll say x greater or equal to what? 1. Okay. Then we can come to this one, then we come to this one. So you can come to this one, which is passing on 3. Okay, we understand that this is x equal to 3 there. Okay, our third one. So x, we leave space, and then we write 3. This one. Okay, so the shaded part is greater, the unshaded part is less. So we are describing using the unshaded region. So the unshaded region, the opposite of this side, which is greater, it's less. So less. Now looking at the line is the solid line, so it's going to be equal to, so x less than or equal to 3. I hope you are following me. So they said 5 inequalities. So we have come up with 1, 2, 3. Okay, so for this line we have said x less or equal to what? 3. All right, so let me just rub here. Okay, then we come to this line here on top. You can see it, this line here. So this is the y-axis and it's on 4. So this is y equal to 4. So how can we write it? So 3, you say 4. Y, we leave space, then we write 4. So the shaded part, okay, is greater than the unshaded part is less. So I'm describing this line using the unshaded part. The opposite, upper is greater, here lower, okay, which is less. So I say less. So looking at the line we have, it's a broken line. So we're not going to say equal to, no, we just say less. This is our answer. So this is the line y less than 4. So I've come up with 4 inequalities. Okay, we are just remaining with this one here, which is our last one. So for this one, I want you people to pay attention, and you can see that it's very easy to describe. Okay, very easy. So I want you people to pay attention so that we answer this one. All right. So for our last one, before we answer it, we have to take note of something for this line. Okay, we understand that this is a straight line. Okay, it's a straight line. So if it's a straight line, we can find the gradient of that line. Okay, so you must know that the gradient of a straight line or gradient along the straight line is equal. So if you pick the coordinates which are here and the coordinates which are there or there, you get the same gradient. So just to make our work easy, let's pick the coordinates. You can see it's passing on this point too. Okay, so you say this is the line y equal to 0. So it's passing on 2. So it's 2, 0. Okay, I can also pick this point here where it's intersecting with this line. Here, y 4, when you come down to x, it's 3. So this is the line 3, 4. Okay, so I'll pick these 2 coordinates. Okay, so I'll say we're answering on number 5. So we say our coordinates, we have 2, 0. Also we have 3, 4. Now I've said that you can pick any coordinates along this straight line and you're going to get the same gradient. Okay, so for easier workout, just pick the ones which are very easy for you, like this point and that point, because they are very visible and easy to identify. So this is going to be our x1, this is going to be our y1, this is going to be our x2, this is going to be our y2. So what do I need here? I'm looking for the gradient of a straight line. When I find that gradient, it's now going to help us to come up with the equation of a straight line. Okay, that's why we are finding the gradient. So what is the formula for gradient? The formula is m equal to y2 minus y1 over x2 minus x1. So upon writing this formula, you just use in, okay? You have the coordinates here. So where there is x2, you put, where there is y2, sorry, you put 4. Where there is y1, you put what? 0. Where there is x2, you put what? 3. Where there is x1, you put 2. So let's fuse it. So you say m equal to y2 is 4 minus 0 over x2 is 3 minus 2. So here 4 minus 0, it's a 4. 3 minus 2, it's a 1. Therefore 1 into 4, it's 4. So the value of the gradient is 4. So what's next? We are going to come up with the equation of a straight line. Okay, this equation is y minus y1 is equal to m open bracket x minus x1. Okay, so you can see, for we have y1, x1, these are representing the coordinates. Then for y and x, these you can just let them be in the equation. For m, we understand that it's the gradient which are found here. So from the two coordinates that you came up with, you can either pick this or you pick that. It's fine. So if you pick this, your x1 is 2, your y1 is 0. If you pick this, your x1 will be 3, your y1 will be 4. Just to fuse in here where there is y1 and x1. So let's say we pick this. So if we pick that, we are going to have something like this. Y minus, where there is y1, our y1 is 0, equal to, our gradient is 4, open bracket, x minus, our x1 is what? 2. Like that. So I do hope that you people are following. I hope that you are following nicely. So just let me rub on top here. I do hope that you are following nicely. Alright, so what are we going to do? So here we just remain with y equal to this, for us to multiply everything inside the brackets. 4 times x, you get 4x. 4 times negative 2, you get negative 8. So this is our equation of the straight line for this line. Okay. Now, this is the equation. So we have to change this now into the inequality. Okay. How can we change it into the inequality? So let's say y, we leave space here. Say 4x minus 8. The way it is, I've left space here so that I come up with the inequality sign that we're going to put here. So looking at this line, okay, this line, we said the upper region is greater, the lower region is what? Less. The upper region is greater, the lower region is what? Less. So we are describing the unshaded part. The unshaded part is this upper region which is greater. Okay, so if this is less, we are using the opposite of less than, so which is greater than. So y greater than 4x minus 8. Now looking at the line that we have, it's a broken line, so there's no need for me or for you to put equal to. So this is our answer. So these are our 5 what equations. Even